Good morning, everybody. How's it going today? Hope you're all doing all right. Just checking the audio. Checking that audio. Yes, good. Excellent. So. Announcements. Silence me. There we go. Good morning. So assignments 1 and 2. First announcement. Assignments 1 and 2. We have released them at this point. However, there's a catch. So let me just speak a little bit. We've talked about this before, but I'll just go over the whole business one more time. With respect to the assignments, we use the JHub server, which is administered by the CAS IT people. We use this server for the assignment distribution and the collection and the marking, largely speaking. However, I don't want to say it's not always reliable. Sometimes there are technical issues that arise which might prevent you from using it. Sometimes this is just a problem with your VPN. In order to access the Jupyter Hub server, it requires a stable VPN connection, and if your internet is cutting in and out, it can be difficult to actually acquire that stable connection that's required. And sometimes it's just a volume issue. In particular, we over the course of the final exam for the winter offering of this course, we were noticing that people were having a fair amount of difficulty accessing the final exam because of server overload, essentially. It wasn't so much that the exam was completely inaccessible. It was just taking, 30 seconds to a minute to actually load the page, which, in the context of an exam is actually, if you're, on the edge of your seat wired for this exam, that could be a very long time. Yes, we do have tutorials today. Yes. Incidentally, issues related to the VPN should be addressed to University Technology Services. It is not a system that we use or authenticate or in any way do anything with. So let me see here. We yeah, it doesn't look like the TAs have posted their. I believe all of the tutorials will be occurring on Teams, so there won't be any links posted in the announcement feed for the tutorials or anything. So I will just over the break, when we have a break, I will verify that, and then we will continue on with our day. So yes, again, issues related to the VPN and getting the VPN and installing the VPN and anything related to that. That's not our bailiwick. That is University Technology Services that you want to talk to about that. So anyway, the early on, when we had to sort of hastily perform the online conversion for this course last winter semester, not this last winter, but the winter that the pandemic started, we we set up an alternative avenue of submission, so to speak, using Avenue. So although this has always been the policy that you can also download the assignments off of Avenue, complete them on a local Jupyter installation, and then submit them, we we were under the distinct impression that a large percentage of the class had simply never bothered installing the software that you can use to do that. And so, when the people were experiencing problems with the final exam, they were sort of, having to go through all of these alternative steps to get there, which just kind of bogged everything down, and that's not really what you want to do during a test, right? You want to work on the test. So, what we're doing this time is assignment 2 will be compulsory submission through Avenue. So it's not going to appear on Jupyter. We are going to require everybody to fill that out on a local Jupyter installation so that you have a local Jupyter installation set up and operational if there's ever any problems in the future. Yes. So the assignments, the assignments will be completed using Jupyter Notebook. Yes. If you are curious what that looks like, I'm just going to pull up a local installation of it that I happen to have on this computer right here, which should be launching inside of my browser at some point. There we go. So this is what Jupyter looks like. You can, you can mess around with Python in this if you want. You can, open up a terminal and do similar things to the sorts of things I do in Linux. If you're on a Mac system, though, be aware if you open up a terminal on a Windows-based system with Jupyter, then you'll be working in Windows PowerShell. So the only main difference there is that in order to get at the Python interpreter, you just type Python instead of Python 3. In Linux, it's Python 3. In PowerShell, it's just Python. But anyway, if you haven't seen the assignments yet, they kind of look like this, except with questions in them. And you have these boxes, and you can code up your code there, and then save it. When you submit your assignment, you are submitting the notebook file itself. The notebook file contains all of the answers that you've typed into it, and then we take that, we run through some algorithms, and then that's everything. Is it okay if you do all of the assignments locally? Yes, if that's more convenient for you, then you're absolutely encouraged to do that. There's no particular... you're not required to use the Jupyter server. Absolutely not required to use the Jupyter server. That's kind of the whole point, is so that you guys have some choice. So, yeah. Let's see. Any other good questions? Yep, good. All right, so so much for the assignments. So far, so good. We also have a note taker who has kindly volunteered. So if anybody requires the services of a note taker, please find Maria's email address in the list of announcements. You can take a look at what she's got, the services she's got on offer. So yeah, there we go. And I think that's everything. I think we can just move directly into our lecture today. Cool. If you want to follow along with the class, can you use Jupyter? Absolutely. Absolutely. 100%. So if you want to follow along, you can either do it in a Jupyter notebook, which, might be, that might be more convenient if you want to, separate everything into nice little boxes so that if you're taking notes and you're doing the programming with the notes, that sort of thing. Otherwise, there are a couple of ways of doing it. If you go to New Terminal, that will open up something that looks like this. If you type Python 3, then you'll get this the Python command prompt that I use frequently in lecture. That's how you can get that from Jupyter. Again, if you're using Windows, you'll have to type Python, not Python 3. And the third way of doing that is you just open up a text file, name it like topic2.py, since we're on topic 2, for just a little bit longer. And then back in the home screen, you'll want to open up a terminal, and then when you want to compile it, python3 topic2.py, and that will execute it. There you go. I know I went through that quickly, but if you need it again, you can always roll the video back. That's why YouTube is better than Teams, or one of the reasons. One of the multitudinous reasons why YouTube is better than Teams. Good. Cool. Excellent. So let's get back into it, shall we? So when we were talking last week, we had gotten nearly to the end of topic 2, and we were discussing strings, their operators, their mechanisms, their what is the point? What is a string? Why strings? Why even strings? So, just to review very quickly, strings are strings of characters. String is short for string of characters. So, in computing, it's useful to be able to deal with characters specifically. Remember that every single value inside of a computer is coded in binary, right? The binary system is a system for representing numbers, not characters, right? You know, when you're writing things in your, in your silly human writing scripts in MeatSpace, what you're doing is, like, your medium of expression has the capability of describing characters. If you're talking about a computer system, the computer system itself, if you consider only the ones and zeros, it's not representing characters. It is representing numbers. So, in order to represent characters, which would be a useful thing, we have to have some mapping between numbers and characters. So we need a table. We need a table to tell us what numbers correspond to which characters. Drop the pen. There we go. Got my pen. I'm not even writing anything. It's just my gesticulation pen. So, back in history, and we're talking like way back to the back in the days of the first electric typewriters, when they had to develop a way of converting type button presses to electronic signals. They developed what is called ASCII, which I believe stands for I don't know, American Set of Characters Internationally Integrated. I don't know, something. Someone in the chat probably knows what ASCII stands for, or we'll look it up on Google very quickly in order to look like they're smart. That's what I would do. So when we have ASCII characters, we have all of the numbers between 0 and 127, which corresponds to 7 bits, and each one of those numbers corresponds to a particular character. Some of these characters are particularly exotic. For example, ASCII character number 7 is bell. So old typewriters would have a bell and a hammer that struck it. So if you hit a bell character, it would make the bell ring. In earlier computers, that was wired to a little speaker on the motherboard that would make the computer beep. That's why old computers would beep when you turned them on, is because they were testing the bell character. I don't think they've done that since, like, 486s, but, you know. So that's been defunct for quite some time. But you get interesting characters like carriage return, which is CR. But, you know, mostly the ones that we care about start at 33, because these are our sort of nominal typographic characters. So, yeah. So characters. So strings are made up of a series of characters, right? The way that we denote a set of strings inside of Python, or the way we denote a string inside of Python, we can use two different methods. We can either use double quotes, hello, or we can use single quotes, hello. Exact same thing, right? Now, some of you who know a little bit about computers, perhaps some of you who have programmed in other programming languages, you may have noticed that I skipped over talking about the character data type. So Python is kind of an interesting language in some of its design choices. One of the design choices that they made when they developed Python is to exclude the possibility of using a single character data type, which is strange and bizarre, because in every other programming language, almost literally every other programming language, you can have a variable that is assigned, that you can assign a single character to a variable of the character type, right? And in most programming languages, the difference between double quotes and single quotes is double quotes denote a string, single quotes denote a single character. So the difference between h, the string, and h, the character, is essentially h is very similar to an array of characters that contains only one character, whereas h is just a single character value. So it's strange, it's bizarre. I don't know why they did it. Probably to hide that complexity, because the Python people were big on hiding complexity from people. But, so whenever in Python you're dealing with a single character, you are actually dealing with a singleton list, or you're dealing with a string that contains only one character. There's no easy way to access a single character variable inside of Python. It just kind of doesn't exist, which is extremely strange and bizarre and weird, whatever. That is, that's just the way they decided to do Python. American Standard Code Interface and Exchange, right. American Standard Code for Information Exchange. Ha! Thank you, Mark. Good. You'll find out as you go through this course, as we go on this journey together through the land of Python, that Python is not necessarily the favorite programming language of your esteemed professor. That's okay. You don't have to like it, you just have to be able to use it. I don't know. Some of the design choices with Python are just a bit bizarre for anybody who knows anything about any other programming language. Anyway, so let's talk about slicing operations. So let's imagine that we had a string, hello world, and let's assign that to a variable s. We can get various subdivisions of these strings using what are called slicing operations. So you are hopefully already familiar with the indexing operation. So in order to get the element at index 6, for instance, or index 7 actually, because everything is 0 indexed. So when you're talking about indexing, everything starts numbering at 0. So s at 0 is h, s at 1 is e, s at 2 is l, etc. If you want the 7th element of this string, you type s6 in square brackets. However, we have more operations that we can do with these square brackets than just picking out a single element. We can actually pick out ranges of elements. So if you want the end of a string starting at some value, starting at some position, you go, you type the the position of the element you want to start with, colon, and then, then you leave that blank. That's actually leaving that blank. And you can see that starts from the W and goes right to the end of the string. Conversely, if we leave the first bit blank here and we enter a number in the second one, we get the front bit. Notice, however, we are exclusive of this element. And if we wish a subdivision, if we want a range from one element to another, we just enter from 2 to 7, and that gives us a subdivision of the string. Again, it's very important to note that what's happening here is you're getting the element for the second one, for the upper bound, it's exclusive of the upper bound. So if in math notation, if we were talking about math bounds, it would be square bracket for the first element and round bracket for the second. You guys have seen that notation, right? For inclusive and exclusive bounds. At any rate. So yeah, we're exclusive of the upper bound and inclusive of the lower bound. And that's how you can take subsections of lists. This is actually an extremely useful thing to be able to do, and normally shows up, well, I don't know about normally, but it often makes its way into test questions, particularly on like the first test. And I know we're only having one midterm this semester, but it makes a good test question. Can you slice lists effectively? Because you can do stuff with list slicing that would take you, lines and lines and lines of code otherwise. The alternative to performing a list slicing operation is to say something like, lower bound is 2, upper bound is 8, new string is an empty string, for character in string. I know we haven't done for loops yet, but congratulations, we're introducing for loops. Well, actually, no, it doesn't even work with a for loop. I is equal to 0, while I is less than the length of s, if lower is, if I is greater than or equal to lower and I is less than upper, new string is equal to new string concatenate string at character I, and I just hit an infinite loop because I forgot to do the thing. I plus equals 1. There we go. What is new string? It is what we wanted. See? So all of that code is what you're replacing when you perform a list slicing operation. So there's this interesting thing in programming languages where it's possible to perform basically anything using only if statements and while loops. However, just because it's possible doesn't mean it's convenient. That's kind of again, it's like if you have a nail and you're trying to hammer it in with a wrench, that will work eventually, but perhaps a hammer would be more to the point. So I really want you guys to think of list slicing operations. Basically think about most of the constructs that we have coming up, except for recursion, which is kind of in its own category, as being things that make your life easier. You'll be more likely to pick them up and plug them into your brain if you're like, you know what, I see the importance of this because it saves me a heck of a lot of work. Anyway, that's list slicing. We also have a couple of methods, these are called methods, that allow us to find either the index at which a certain thing exists in a string or the number of instances that we have of something in the string. So s.count L gives us 3. There are 3 L's inside of the string hello world. If we want H1. Notice that this is case sensitive, so there are 0 capital E's. Again, you have to think of looking up a character as looking up a particular character code rather than, you know, I am looking up the letter E. Because if you think of it in terms of character codes, you will be less likely to make the mistake of thinking that you will be hitting both upper and lowercase e when you type in the letter E. Although Python makes a lot of things convenient, it can't do everything. And that's one of the things it doesn't do. The other thing that you have, pardon me, speaking. Index gives you the first index at which you find a particular character or substring. So s at that to the end, the first element is O. And not this one, but the first one. So there you go. And also, both count and index will search multiple... they'll both search for strings containing multiple characters, not just one character. So, for example, if you want to count the instances of a double L, you only have 1. And length works the same way on tuples as it does on strings. Let me see if we have any questions. Oh yeah, I should mention negative. So one other cool thing, and this is one of the things that Python does, which I think is actually useful, is you can actually use negative indexing in Python to count from the back of a string rather than rather than counting from the front to the back. You can actually count from the back to the front if you use negative numbers. So s at 0 is the first element of the string. S at -1 is the last. It's the last element of the string. And as you go through the negative numbers, you can see that we are barfing up that string in reverse order. That is kind of useful. It's kind of cool. And I'll just show you one more little trick, which is cool while we're at it. If you want to reverse all of the elements of a string, it's : -1. And that... so there are 3 arguments here that you can use, actually. If you leave the first one out, that means from the beginning. If you leave the second one out, that means to the end. And the third one is how much you count by. So if you count by -1s, that means you're going from the back of the list. That means you're going backwards. So you can print the list out backwards. If you're going by from the front of the list to the back, by 2 means you leave out every odd-numbered character. If you go by 3, you can... you take every third element, starting with the first element. So yeah, that's some cool stuff. So, strings are immutable. We talked about immutability a little bit with tuples, but what that essentially means is that if you're accessing an element of the string, let's do one that isn't space, although it is useful to note that space is a character. It's not just space, it is a space character. Because you hit the space bar, you create a character, and that character fills space. But anyway, it is impossible with a string to perform an assignment operation on a particular index. If we try to access element number 3 and assign some other character to it, we get string object does not support item assignment. If you remember, that's the same error message we got when we tried to do the same thing with tuples. Strings are immutable. Strings are immutable. So, yes. You can, if you want to modify a string, you can use a construction like this. S is equal to S plus exclamation mark. But what's actually going on here behind the scenes is we are taking the string hello world, we are taking the string exclamation mark, we're opening up an entirely new segment of memory distinct from both hello world and the exclamation mark, which are held elsewhere in memory. We're opening up a new one. We are performing the concatenation operation on those two old strings, putting it in the new memory chunk. Then we are taking the S variable and we are redirecting it to point to the new memory chunk. This is kind of getting into like memory management type stuff that typically we don't worry about too much in Python, but it's still useful to know. So, yes. Here are a couple more operators on strings. So in the same way that we had concatenation on tuples, we have concatenation on strings. I just demonstrated that, in fact. We have, if you remember, we had an in searching operator in on tuples, and we have that on strings as well. In fact, in works on most data structures. So is capital H in S? False. Is that true? Oh. Yeah, S is not in H, but the question is H in S? That's correct. However, is the tilde character in there? No, the tilde character is not in there. So, we also can repeat a string X number of times. So, if we have that's 1. Multiply it by 5. 5 so it goes from to And if we want to just have infinite screaming, there you go. We have generated a string of 10,000 characters, all of them the capital letter A. We also, and this one's actually more useful than you might think, especially if you're doing file I/O and you want to test to see if the string that you received actually has the correct file extension. Ends with. So here is S. So S ends with exclamation mark. Oh, I used capital here. There we go. True. Ends with 2 exclamation marks. Yes. Ends with 3 exclamation marks. False. There you go. So what this does is it will compare, it'll compare the string that you give it to the terminal characters of the string that you are calling the method over. And if that method, like if those match, then it returns true. So there you go. Let me see if we have any questions. Why is the result of A plus 5 A instead of A5? Yes. Well, because that's the interpretation of the multiplication operator when it's applied to a string and an integer, right? 5 without quotes, that's an integer. 5 with quotes, that's a string. And you can't multiply a string by another string because this is not being interpreted as a numeric type. Now, if you wanted to, you could multiply it by whatever the ordinal is of 5, which is to say, you could look up the 5 character in the ASCII table, use that number to multiply a by. You can do that, but that converts the type here to integer. One of the things that you guys got to really get on top of is understanding that literals and variables always have a carrier type. That is to say, they have a data type. All variables, it's a property of variables. Variables, you can think of a variable as two things. You know, it's the value itself, and also it's a type, right? A type gets bundled with the value of the variable because, like, the type is super important for how the variable is interpreted. And this actually goes all the way down, like, past the operating system, past the kernel, right into the sort of heart of your processor. You know, if you look at the binary format in which a floating point number is stored versus an integer is stored, they're very different formats. In order to correctly perform something like addition over floating point versus integer, the computer absolutely must know whether the variable is a floating point number or an integer. So that information is associated with the variable itself. Now, the problem with Python is that they consider, the people who designed Python consider that to be extraneous information that's not strictly necessary in order to know what, to know how to program. But they're wrong. They're dead wrong. If you don't understand what the data type of the variable you're operating with is, then you're going to make mistakes like confusing 5 for the character 5. And they're very different things, right? So in other programming languages, you would be constrained, right? When you declare a variable, you have to declare it with its data type up front, and that data type may not change. And the compiler will throw your code back in your face if you try to use a variable in a manner in which it has not been designed to use. However, because Python is all this loosey-goosey, you know, ooh, everything is everything else, you know, hippie world of Python, what Python allows you to do is it allows you to implicitly convert between data types without even realizing you're doing it, which it just introduces a whole class of errors, which is, which you wouldn't necessarily have to deal with in other programming languages because you're more strictly, rigidly typed. It actually cares whether the variables that are being used are actually being used in the manner in which they were intended, right? And, like, there are good reasons for this, too. If you declare a variable of one type, that will take a certain amount of memory. If you declare a variable of another type, that might take a different amount of memory. And, at the binary level, you don't want to be too free between two, like, different sizes in memory. It just tends to start exploding things. But yeah, can I go over this loop again? Which loop? I'm not sure which loop you're talking about. So if you want to print stuff to the console. We've done this plenty of times before, but print hello world. It doesn't really make a huge amount of difference in the terminal because the terminal is configured to automatically print the result of whatever operation it performs anyway. But you can perform string operations inside of these, and you can still get the result. So one of the things that I'd like to break you of the habit of is imagining when you are providing an argument to a function that argument has to be like one literal or one variable. It can be an expression, right? You can print 8 plus 9 divide by 2, and it works, right? That's because the computer will evaluate the expression before passing a concrete value to the function. Remember that the computer will always deal in concrete values. Cool. We also have a method for gathering input from the user. This is not something that you'll do a whole lot of in the assignments, but it's still useful to know. So if I type input and provide it with a string, please enter a number, and I assign the value there to, if I assign the return value of the input function to a variable, please enter a number, 9. What is the value of x? It is 9, right? So it doesn't, I don't have to follow instructions. So please enter a number, potato. X is potato. Notice that x is a string, right? Just because you've asked for a number and entered a number does not mean that it will interpret what you enter as an integer automatically. Computers are stupid. You gotta tell them if you want it to be an integer. And the way that you do that is by saying x is equal to integer x. So because x is potato, and potato is not an integer, we actually get an error here. Invalid literal for int with base 10, potato. However, if we had entered the number whatever, and then attempted this conversion, then notice the quotes are gone. This is now an integer that we can perform regular integer arithmetic with, rather than a string, where strings would only you can't perform integer arithmetic over strings. So yeah. Boop. Oh yeah, you don't have to define ASCII. Every computer uses ASCII, right? Everything uses ASCII. This is not so much me telling you something you have to do as letting you in on the secret of how things actually work. So, yeah. So, So we also have a format string. This will be more interesting if you guys ever end up studying C or other programming languages. But essentially, you can leave these spots you can leave special spots inside of strings, denoted by these curly braces in Python, which you can insert stuff into. And the format function will take values of any type and format them according to special formatting rules that you establish by specifying characters within the curly braces. So if I want to insert a string, you do .s, format, and then throw a string at it. There we go. No. Dot format. Bob. Attribute error. Oh, yeah, I'm using... Sorry. I was using period when I meant to use colon. There we go. So you can see we just insert this guy in there. This can be useful when you're trying to create... like if you were trying to create a chart, for instance. You know, we can whip up something real quick. So, int I equals, or I'll use a for loop. Just show you what a for loop looks like. For I in range 20. Oh, gotta use a colon. Print D tab D tab dot format I times 2 I times 3. Oh, I forgot the third one. There. So you can see we're doing our multiplication tables. So it's S for string, D for integer, F for float. You can specify a number of decimal places using point and then a number. So if you have a number like 0.1, right? Colon dot 5 float dot format the floating point number 0.1. So you can see it's 1.00000, and if we expand this, you can see why. Haha, see? So remember that bit that we were doing earlier, how 0.1 isn't equal to exactly 0.1? Well, if you show 20 or 30 digits of that number, you can see why. Right? It's only 0.1 to, like, 16 place values of accuracy, I think. Yeah, or 18. 17? Yeah, it's 16. 16 place values of accuracy. That's why when you start performing arithmetic on floating point numbers, the errors will accumulate. This guy will start to build up and build up and build up over time through floating point operations. But you can't see it unless you show the decimal places. And this is how you can show the decimal places on a floating point number. We're going to see that later on as well. Let me see. What happens if you leave the decimal place off? Good question. Let's see. Oh. Basically, what it's doing here is it's it's requiring the string to be a certain like a certain width. There are actually a whole bunch of these formatting options, like a whole bunch, and they are very ancient. They go all the way back to I think a lot of these conventions were established when C, the programming language C, was established, and they're borrowed by Python. Because on the back end, Python is using a whole bunch of the C libraries, so a lot of the ways in which, like a lot of things, like the manner in which these guys are interpreted is actually the same as how they are interpreted in C. I know I talk about C a lot, but there's a reason for it. So, my goodness, fit page. Width? No. Page. There we go. So, good. I'm going to skip that example because we've done lots of examples. So, you know, I want to get this. I want to close out this topic before we have the break, and I want that to be quickly. So, we also have a conditional operator in, this is kind of a different topic entirely. So, when you have different lines of code, each line of code is a statement. And statements are composed of, you know, a certain amount of syntax plus expressions, right? If I say x plus x is equal to 4 plus 3, 4 plus 3 is an expression, right? But x equals 4 plus 3 is a statement. Up to this point, we've been doing if statements as statements, but we can also do if expressions. These are generally called ternary operations. So I can say, all in one line, x is equal to 4 if some condition B, say 8 is greater than 2, else 9, and x will be 4. So you can squeeze all of that into one line if you really want to. You can jam it all together, just compress it. I'm not sure why you would need to, as a learner, as an as an introduction to programming. I'm not sure ternary operations are really like 100% required material, but here it is. If you ever see this in somebody else's code, you know, after you get out of this course, then this is what they're doing. This is a conditional operator. Cool. All right. And just to round things out, we have some boolean operators as well. So remember, we have true and false, which are boolean values, right? So true and false is false. True and true is true. So this is a way of being able to compose multiple conditions together. If you want the expression to come out true only if both of the things that were put into it were true, you use and. If you want the expression to come out true if either A or if either condition B or C, calling the two conditions B and C, if you want either of these to be true, you use an or operator. Pardon me. And if you want it to be true only in the case where one or the other of them is true, but not both, you use XOR, which is an exclusive OR. It's exclusive of and you use the caret character. So these are super useful. You will use them a lot. And OR. You also have negatives. So not true is false, and not false is true. This is Boolean logic. You only have two states of existence, truth and falsity. So you can actually have fairly expansive expressions that are these Boolean expressions can get pretty long. So let's do this one, right? Let's not do it in the Python terminal though. Let's do it on paper, so to speak. So we have this expression, not x and not y, or y. And our initial conditions here were that x is true and y is false. So x equals true and y equals false. So if y is false, the first thing you do is you substitute in, right? Because this is the first thing the computer does, is to take all of these values that were variables and substitute in their actual concrete values. Now we begin evaluating in the same way that we would evaluate using bedness. So not false is true. I'm just going to use T and F. What's true and true? True and true is true. What's not true? False is not true. False or false is false. Not false is true. Therefore, Z is true. There we go. Cool. So, that is, we'll call our first break there. Thank you very much. When we come back, we will continue on. Since I've got you DA guys in the chat now, you guys are doing your tutorials on Teams, all of you, right? I believe you guys were doing it on Teams. Yeah. Anyway, we'll take a quick break. 10-minute break. Meet me back here at 10:37 on the dot. Hello, welcome back. So, let me just pull up content topic 3. Statements! We're going to learn how to make a statement. We just learned how to express ourselves, and now we're going to learn how to make a statement. All right. You know what? Let's just download it. Download. Give me 2 seconds, guys. There we go. All right, I've got it in my favorite PDF viewer. Everything is cool. Everything is copacetic, and we may continue on. So if you'd like to go over string formatting again, I think that perhaps you should ask your TA if you have some time for that in your tutorial, because we got to keep moving. I got super behind on the lecture material last semester, and it was terrible for everyone, and everybody hated me because of it. I imagine I probably suffered unduly in my course evaluations for it. So I gotta keep on schedule. Sorry, guys. So he says already being a full lecture behind schedule. Well, a full hour behind schedule. That's actually not too bad for me, but anyway. So let's talk about statements. We have been using statements. Statements are, I actually already talked about the definition of statements immediately before we entered into this particular topic. But, while we're here, we might as well go through it. So, remember our flowcharts, our basic instructions. Basic instructions can be thought of as single statements. Sequences of instructions may be thought of as multiple statements chained together. So when you write a program, you are chaining multiple statements together, unless you are programming in a language that does not support statements, in which case, what the heck are you even doing? Let me save this as, no. Get out of here. Get out of here, you. Get it. Topic 3.py. Bing, bang, boom. So, if you were to say x is equal to 9, y is equal to 8, and z is equal to 37, this is a series of statements. These are assignment statements, and we execute them one after the other because they have been written in a linear sequence. This is how programs work. You start at the top, you move down to the end, you follow each instruction in turn, and the following of instructions might also change where in the file your currently executing instruction is. That's the point of control flow statements. So, in our flowcharts, we also sometimes have these circles which denote start and end points. Remember our if statements if-else statements and loop statements. These are the basic constructions. All other programs can be expressed using these basic instructions. Everything except this is to make life easier. So, and remember that S, S, T, and S here may be sequences of, sequences of instructions, not just single instructions, right? So, one thing that gets people, and you're going to see this in tutorial, is that you can actually tuck these constructions into each other. So if, we saw this with the max min, or sorry, the median example. You had like if blah, then if blah something else if blah some third thing, right? You can create these branching structures and like these nested structures of if statements and loops, and there's no limit to the amount of nesting that can go on. So, and that's kind of how that's how you can represent any program with this stuff, is the infinite nesting. So, in Python, we have the following equivalencies. So, if B S, if B S else T, and while B S. You will have seen these a few times already. Very important thing to note, Python uses indentation to group nested statements rather than using curly braces, which is what a lot of other programming languages use. So you can tell that all of these constructs are inside of this branch of this if statement by the fact that they're all indented at least one level from this colon. Like, the colons also denote... I'm not quite doing things correctly here. Generally speaking, in Python, what a colon means is the next line should be indented. And for however long you hold that level of indentation, you're saying to Python, all this stuff goes inside this if statement. So if we evaluate this if statement to true, we then treat this as if it were a sub-program, and we go through it in the same manner as we would go through our regular program. We start at the top, start executing in sequence, until we hit the end, and then we continue on with what we were doing before we entered it. Cool. So let's talk about a particular example that we're going to use for a number of different things, the factorial. So you may remember factorial operations from combinatorics, probability and statistics, maybe. The factorial of a number is every number that went before that number multiplied together in the natural numbers. So the factorial of 5 is 5 times 4 times 3 times 2 times 1. These are a way of counting permutations. So if you have 5 objects, the manner in which those 5 objects, the number of ways in which those 5 objects can be arranged is 5 factorial. So let's come up with an implementation of the factorial in programming. So define factorial of some number n. I is equal to 0 while I is less than or equal to n. We'll do something, but we know we need I to increase. let's say product is equal to 1. I will start this at 1, actually. Product equals product times n, or I, because we're going all the way up to n. There we go. And just to be interested, just to make this interesting, let's just print and see what the values of I are. And then we wish to return the product. Print product. Or, sorry, not product. Factorial of 6, let's say. Python 3 topic 3.py. Nothing. Save. I hadn't saved it. There we go. We can also take a look at what our running product is. I suppose I could also be using Python Tutor for this. But you can see, as we execute this loop, the product accumulates the values that we want until we eventually hit the final value of 720. So there you go. We have while loops. We can also use if statements here. So notice that the factorial of 0 is considered to be 1. That wouldn't work with this product notation because, anything multiplied by 0 is 0. So if we start, I at 0, then, we get 0 each time, right? And if we ask for the factorial of 0, we get, well, actually, that still works. We get 1. Yeah, so we don't actually have to do anything. So the way that that's working, right? If I is 1 and n is 0, then I is never going to be less than or equal to n, right? 1 is never less than or equal to 0. That's always false. So this while loop will actually never execute at all. Execution will jump over the while loop completely immediately to the return statement. Because product happens to have the value, the correct value for the n is equal to 0 case, then everything just works out. Everything's hunky-dory. Cool. Right. So that's good. Where are we here? There we go. No! Get out of here. There we go. So, you can see that this is basically the same thing that the slides are doing. However, just to make the notation somewhat more compact, they are using multiple assignment, which I just think is confusing, but if they want to do it, then they're welcome to it. You are not required to use multiple assignment for any assignment, so to speak. Pardon me. So, here's an interesting thing, though. Let's say, what happens if we attempt to print, for example, product in main execution? Generally, when you hear me say main execution, what that means is any statement that has no indentation whatsoever. Stuff that's inside of a function definition will always be indented by at least one level. When Python executes a file, it goes through things in sequence. When you hit the definition of a function, it doesn't actually execute that function. What it does is it defines the function. It records the function and says, okay, this is a function. Then you can use that function later on. So, if you if you put the use of the function before the definition of the function, you'll get a name error. Name fact is not defined. So you always want to define your function before its use. That's why the function definitions are always going at the top when I do all of this. But anyway, so if I want to access product here, I get an error. Name product is not defined. But you might say, it is defined. I'm using it right here. How does the computer think that it's not defined? That's strange. Well, I'm so glad you asked, dear viewer. The product variable inside of this function is what we call local to the function. This is introducing a concept of variable visibility. Now, it's not quite so easy as all of that. And let me just open up Python Tutor, because it actually demonstrates this pretty well. So what happens when you execute a function is you can think of it as the program opening up a new workspace, specifically for that function. Any variable which is declared within that function is contained within that function's workspace. Right? So I define I gets added to this function's workspace, product gets added to this function's workspace. I then go through, in this particular case, we're skipping the while loop. So the return value of the function is found, and its value is 1. That's going to be returned back to main execution. But once we return to main execution, notice that the frame, the workspace for that function is removed. This is correct. When a function is finished executing, once the return value has been found, the workspace for that function is deleted, and everything in it is also deleted. So the variable product no longer exists. Product no longer exists, I no longer exists, and any arguments also no longer exist. They are all wiped from existence. They are deleted, disabled, destroyed, annihilated. So, when you try to, if you try to access them after the stack frame for that function has been deleted, after the workspace for that function has been deleted, it's like, I don't know what you're trying to get here. Name error. Product is not defined, because it's like looking around and it's like, I don't see a product here. Where's the product? What are you talking about with product? I don't see no product. So, and that's because there formerly was a product, but now there is no product. So, it has been deleted. So what we say, then, the way that we talk about this, is we say that product is local to the function. That is to say, it does not exist outside of the function. Product cannot exist outside of a operating instance of that function being executed. So, when you try to access it outside of it, it's like, nope, doesn't exist. That's a very important thing to know. This is called scoping. So we also say that product is scoped to the function. So, in general, when we talk about scoping, we talk about local versus global scoping. Product is local to the function and does not exist within the global space. This is in the global space. This is in the local space. There are ways of getting around this that we're going to see in a bit, but we don't have to worry about that quite yet. So, here's the same thing without using multiple assignments, which is the way I did it. Sure, fine, whatever. You can also include multiple statements on the same line by including the semicolon character. This is not particularly useful, but it's possible. I'm not sure why you would do this, again, but it's a possibility. It's worth noting that in most programming languages, semicolon is used to denote the end of a statement. So in most programming languages, you would have a semicolon at the end of every single statement. The semicolon itself says this is the termination of that statement. However, in Python, again, it's one of those little details that they considered to not be useful. Also, however, well, that's kind of a facile way of saying it. It's not that the semicolon isn't useful. It's that in Python, they accomplish the same thing with new line characters. So when you press enter, it is it's considering that to be a new line, or it's considering that to be a new statement. That's the statement separation. Whereas in a programming language like C, it's only conventional to put every statement on a different line. It's actually possible to write the entire program all on one line if you really want to. It'd be almost impossible to read because you're not following any convention, but that's one of the things that Python does. It takes programming, like style conventions for programming from programming languages like C, and it actually codifies them as things carrying semantic content. So, yes. Boop. Let's see. Have I lost everybody yet? Burp. Cool. So in this example, we had decided to count up from 1, but it's also possible to count down from n. So if we assign I to the value of n, and then wait for I to be greater than, or we only execute this while I is greater than or equal to 1, rather than less than or equal to n. And if we modify this to subtract 1 each time the loop iterates, rather than add 1, we essentially get exactly the same thing. Precisely the same thing. Let me just make that more interesting, though. So rather than counting up from 1, we're counting down from n. This is fine. This is a perfectly acceptable way of going about things. This is kind of what I'm getting at when I say that your programming code is much more unique to you than you might think. When you're programming, you are constantly making these types of small little design decisions. A lot of them are inconsequential. Like in the case of the factorial function, it makes literally not one whit of difference whether you're counting up from 1 or down from n, at least with respect to the final result. But, you know, the code is still different. So this should sort of give you this idea that many, many, many programs may be written which produce the same result. We may also modify n directly. So the way that arguments work in Python is it's passed by assignment. So if you take a look within the Python tutor environment, notice that n is a variable inside of factor's workspace, or factorial's workspace. This actually means that we can modify it directly. This is sometimes not recommended, but so if while n is greater than or equal to 1, n minus equals 1, doop, 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 get rid of that. Oh, there we go. Get out of here. So you can see that n starts at 6 and is counted down, and by doing it that way, you save yourself an entire variable, which, you know, if you're into saving memory, that's not a bad way of doing it. So, we need to make a distinction here. So n, within this context, n is known as the formal parameter. N is scoped to the function, so n does not exist outside of this function. Whatever is provided when the function is actually called, this is known as an actual parameter. So in this case, the actual parameter is 6. If we had some variable x, which was 6, and provided that variable x to the function, it's very, very important to note that we're not saying that x is the same thing as n here. All we're saying is that we want to take whatever the concrete value of x is and assign that to n. In the same way that if you say n is equal to x, you're not, let me see here, Python tutor. There we go. So let's say x is equal to 9. If we say n is equal to x, right? N is 9, x is 9. If we subtract 3 from n, we get 6, but x is unaffected. That's the same relationship between anything you put into an argument of a function and the attributes when you're inside that function. Now, if you were to say x is equal to factorial, then what you're doing is you're reassigning x to the concrete value of the return value of the function once it's been executed. But that's kind of an entirely different thing and has nothing to do with the input parameters. So there you go. And that's basically what I'm saying. So in Python, we call this pass by assignment. So n here behaves as if there was an implicit assignment operation as the first line of the function. So the behavior here is like we took n is equal to x, and we made that the first line of the function, where x is the thing that is external to the function. So whatever the behavior of assignment is in any situation, in any capacity, that is what passing it as an argument will do, because it's passed by assignment. Cool. By the way, I'd just like to say thank you to all of you wonderful TA people in the chat who are fielding all of these questions. That's extremely helpful. So, in general, while this is possible, it's not necessarily recommended. It's not recommended for a couple of reasons. One, it makes things more implicit rather than explicit. And whenever you make things implicit, whenever you hide what's going on, it makes it more difficult for your code to be read by yourself and by other people. The other thing to keep in mind is that whether or not you can get away with this depends on the programming language that you're currently using. Some programming languages, like BASIC, Visual Basic, I believe, use pass by reference rather than pass by value or pass by assignment. when you're in a situation where you're using pass by reference, any modification within the function to the arguments that are provided to the function are actually seen outside of that function. So the behavior can change in unexpected ways if you rely on this type of thing for your, if you rely on that as being the way you program, then your programming style will not be very transferable between many different programming languages, essentially. And you may have been noticing this, but one of the things that I'm sort of consciously trying to do for you guys as we're going through Python programming is to try to make sure that your programming skills aren't too brittle. I don't want you to be I don't want you guys to be excellent Python programmers. I want you guys to be excellent programmers who know Python, right? Which means programming in such a manner that your programming skills are transferable between programming languages. That's an extremely helpful thing to have. So, yeah. Anyway, so let's talk about some extra topics. So you may have noticed when I do loops, I use some common constructions. It's not that this is the only way to use loops. I can show you many examples of loops that use neither counter variables nor accumulator variables. But when you're going through a data structure, a linear data structure that has indexes, it's useful. When you're doing one of these numerical type problems where you're trying to accumulate, like you're trying to count some value or something, it's useful to construct a loop like this. So we have, oh my goodness, there we go. So we have two variables that are very commonly used inside of loops, while loops in particularly. We have the counter variable and we have the accumulator variable. The purpose of the counter variable is to control the loop itself. So in this case, I is our counter variable. I is used to control the loop execution, and I is modified slightly each time the loop executes. We also have the accumulator variable. The accumulator variable accumulates the correct result. So if we were taking a sum of a list, the accumulator would be a running sum as we move through the list. In the case of factorial, it's a running product as we run through all of the numbers before the number n in the factorial productation. I want the product term for summation equivalent, grammatical equivalent. Anyway, so f is the accumulator because it accumulates the eventual correct result. I is the counter because it's counting through the loop iterations. Very, very common things. Counting can go up from the lower bound to the upper bound or down from the upper bound to the lower bound. And the accumulator must be initialized to a value that is correct if the loop is not executed at all. So you remember how I was so pleased with myself that our factorial functions works for n is equal to 0 without having had to put in a special if case for that specific instance. And that's because product was initialized to the correct value if the while loop is never executed at all. So yeah. That's a common type of error that you can hit, which, you know, it's good to make common errors because then you can figure out how to fix common errors, and that's a very useful skill. So I think I'm going to skip this guy, except to point out what happens. No, I won't. I'll skip it as a quiz, but we'll still go through the code and see what the result of it is. So we have a summation function. We have a counter variable. We have an accumulator variable. While I is less than the length of t, s plus equals t at I. Return s. So does this return 15, 30? Does it return an error, or does it not output anything at all? Well, in this particular case, it doesn't output anything at all. We forgot to increment the counter variable. The increment step, of course, is this bit where we modify the counter, right? Because the counter is not being modified, as we execute this loop, I is never changing. Because I is never changing, you will never have I being greater than the length of t, right? Because that will never occur, this loop will execute literally forever because computers are stupid. So, yeah. The way to fix this would be to just insert the line I is equal to I plus 1 after this summation, and everything would work. The eventual result would be 30. So there you go. When a loop or any other, when a while loop or any other type of loop runs without terminating, we call that an infinite loop because it will run indefinitely. Normally this occurs because we forgot to increment a counter variable. That is a very common type of error. I will make it myself many times in class. In fact, I made that same error in the first segment today. Depending on what environment you're in, there are different corrective actions that you need to take to stop an infinite loop, but they're sort of all in the category of you need to interrupt the program because it will not interrupt itself. So if you're in the Python terminal and you just have a while true pass, which is the simplest infinite loop, it'll just run. Control C on your keyboard. Keyboard interrupt stops it in its tracks. And that works on any program, actually. If you want to stop a program or a statement or anything from running, Control C generally will kill it. Let's see, in this guy, in a Jupyter notebook itself, if we try the same thing, while true, pass, Shift-Enter executes, by the way. The star means that it's currently executing. If you hit the stop button, that stops it. It's the same thing as the keyboard interrupt. Just hit the stop button. If you really have a problem, this is a local instance of Jupyter, so it doesn't work here, but you can just kill either your local instance of Jupyter entirely, or if you're on the server, you can go in and stop your server and continue on. There are instructions on how to do that. And if you're in a Python file itself, while true, pass, save, and you are executing that from a terminal as a standalone executable, it'll just run. Control C, keyboard interrupt. Control C interrupts everything. Yeah. The other thing is, if your kernel just kind of suddenly stops, that can also look like an infinite loop, and you gotta just you gotta go in and restart your server. Very true. Thank you, Mark. So, one final note: type conversions or typecasting. So, Python will explicitly convert between some types. So if 2 plus 1.3 produces a float, 2 is implicitly changed to a floating point number so that floating point operation can occur. You don't have to do it explicitly. However, generally speaking, if you want to convert, for example, a float to a string, you use a function with the name of the type that you want to convert to. So string interpretation of 3.14 is that's already a string. Sorry. 3.14 becomes 3.14. If you want to convert the string, I already did this earlier today, but if you want to convert this number to an integer, you use the integer conversion function. It actually turns out that you can do all kinds of different stuff. So if you want to convert the string hello world to a tuple, you can do that as well. It breaks the string apart into its individual characters and makes each one of those characters an element of the tuple. You can also string, I believe you can convert that back to a string, but it does it a little bit differently than you might think. It takes this printed out version of the tuple and it converts that to a string. So, you know, in that case, it like going between strings and tuples can vastly expand the amount of junk in your, you know, you can just it's like a multiplicative factor of junk that accumulates over time. Ta-da! You can see how far spaced out the H-E-L-L-O-R when you do that. Yeah, do while is a C thing, not a Python thing. So, it's 11:20. We just finished one topic and about to start another, so I think we'll call another break here. We'll meet back at 11:30. Okay, folks? See you shortly. Hello, everybody, and welcome back. Welcome back to Lectureland. We were just about to get into if statements. You may think, I've already got this. There's not much more to be said about if statements. What could possibly there be? Well, just one thing, really. And that is the elif statement, which we've not really talked about just yet. So, it turns out that sometimes you want to select between a number of different conditions, rather than just the one and its negation. So a good example of this is if, for example, you wanted to say you had some variable, it's like 7. If x is equal to 8, do something. Elif x is equal to 9, do something else, and else do some third thing. You can also, this is also very useful for stuff like, you know, selecting between different characters that a variable might be. I'm just going to check to make sure I'm coming through. Okay, good. One always has to check. So, another, useful, like if you wanted, for example, to see if, x was a vowel, or x is, a number, not a numeric character, that is, this would be another way of doing it, right? So, print, it's a vowel. You can even do the lowercase ones if you want. Print, it's a number. There you go. Print, it's a nothing burger. So, if we execute that, oh, that's not what I wanted. There. In this particular case, it was a nothing burger. So, so you can see how things work here, right? These do not have to be mutually exclusive. A good example, another example. Let's say that y is equal to 10. If y is less than 5, print this. If y is less than 12, print that, else print the other. So in this particular case, because y is 10, this condition will come out false, but this condition will come out true. So the result is that. However, if I modify this to something like 3, that'll hit the first condition. Notice that we get, oh, I'm sorry, I used if instead of elif. That's, okay, so that's actually very interesting. That's the difference between an if statement and an elif statement. So, if this is an if statement, then all you've done is you've written 2 consecutive if statements. If it's an elif statement, then you have an exclusivity between them. So, because it's elif, when I run it, I get this, and not that, right? This statement is hit, but this one is not. And the reason for that is that y is less than 5, this statement executes, or sorry, this condition is true. So because this condition is hit, no other case in the elif construction is executed, because it's like the first one you hit, that's the one you go with. And again, that's the difference between that and putting an if statement there is that each condition will be evaluated separately, and the contents of them will be executed separately, not in relation to each other. So there you go. Your VPN keeps disconnecting. Nope, that's not normal. Probably having to do with a poor or unstable internet connection or something. I'm not sure. You should talk to UTS, but you should also you should try for the offline version of things. Sounds like to me. So there you go. So we're gonna go through a similar example that relates to divisibility. So we can write a simple function that determines if a number is even or odd. Remember, evenness or oddness can be determined by taking the modulus of the number with respect to 0. If you can divide the number evenly by 2, then it's even. Otherwise, it's odd. So now we'll write a function that determines divisibility by 2, 5, and 10. So here's a question. What is the output here? Right? So we've got if n mod 2 is 0, return by 2. Elif n mod 5 is equal to 0, return by 5. Elif n mod 10 is equal to 0, return by 10. If we print the divisibility by 5, comma, the divisibility of 10, what's going to happen here? With 5, this condition will come out false, so we won't print that. But this condition will come out true, so we will print that. With 10, is 10 evenly divided by 2? Well, yes, so this will come out. This first condition will execute, so we'll get by 2. So it's actually impossible for us to hit this final case, because anything that's divisible by 10 is also divisible by 2, right? Because that's how factors work. So the answer here is by 5 by 2. So what if we invert the order of the operations? What if we test for divisibility by 10 first? Well, in that case, we will, in fact, get by 5 by 10, right? Because the first conditional that comes out true is the one that we go with. So we'll get by 10 by 5. What if we nest this inside of there, though? What if we nest the test for divisibility by 10 inside of the test for divisibility by 2? Well, in this case, we get the same behavior as if we had put the test for divisibility by 10 first. So when we enter in divisibility 10, this condition comes true, right? So we enter this statement block. We then test to see if it's divisible by 10. That will return true, so we return by 10. If it had not, then we would get by 2. So we would still get by 5 by 10 in this case. Another fun way of doing that, anything that is divisible by 10 is also divisible by 5 and 2. So we could compose the test, rather than having mod 10, we could have mod 2 and mod 5 both coming out as 0. So yeah, divisibility. I'm going to skip Spectre because it's not... I don't like this unit. I don't know why it's in here. It's not tested on. It's not really relevant. If you're interested in it, Spectre was a bug having to do with... basically, how Spectre worked was... so what is Spectre? I'll go through this quickly then. So Spectre was a bug in AMD CPUs So right there in the CPU, which means there's very little you can do to fix it once it's out there. Modern CPUs do a lot of different work in the back end to try to speed up execution. One of the things that they do is what's called if statement branch prediction. So you have an if statement. The computer doesn't know what branch is going to be executed until it gets there, but it can predict what the results would be of one branch versus another. If the computer is like tied up in some other operation, it can look down the program a little bit and predict what some of the outcomes are going to be, and then use them, and that speeds things up very slightly. However, what that means is you're caching intermediate results somewhere in the computer. It turned out that if you poked the program in just the right place at just the right time, you could actually get the computer to reveal the results of those intermediate predicted calculations, and therefore, data that didn't belong to you could be accessible by you, which is generally speaking what we consider to be a data breach. So again, not super important, the Spectre stuff, but sort of generally on the subject of hacking and hackers, any situation in which data that shouldn't be accessible to someone is accessible to someone will be used by hackers to extract sensitive information. That's just how hacking works. So in computers, we generally have what's called the principle of least privilege. So and that means that any program should only have as much access to your computer system as it needs to perform the operation it needs to perform, and no more than that. So it would be ridiculous, for instance, for your Paint program to have access to your word processor, right? There's no reason for your Paint program to be able to modify your word processor, so it can't, or at least it shouldn't. This also applies to users, right? So, a good example of this is the Jupyter server system itself. You guys have the lowest level of privilege on the Jupyter system, right? You, as student accounts, only have so much access, right? You don't have access to the gradebook. You don't have access to the auto grader routines. You don't have access to, what the auto grader tests are. All that stuff is above your privilege level, right? And for good reason, because, if you guys had access to that kind of stuff, you could very easily game the assignments and stuff. So, so you're kind of kept out of it intentionally. We, the TAs and myself, have a higher level of privilege than you, the students, because, we need to do more different types of things with the server than you guys do. We need to be able to collect assignments. We need to be able to mark the assignments and distribute stuff. So, we have access to Exchange folders where we can place material. We can place material in Exchange folders that you guys pick up. You guys, that sort of thing. We have access to functions you guys don't. But we're not the top level of privilege. The IT guys who run the server itself, they have the absolute top level of privilege. There are some functions that the TAs and I can't do that can only be done by the IT guys in the CAS department, such as new user account creation. We can't create a new account. Well, I don't know. Maybe they gave us the ability to do that. I'm not sure, because it was so much of a pain us going to them asking for new accounts all the time. I don't know. Certainly, though, like stuff related to the very deep down settings of the server itself, that's stuff that the IT people have access to that we don't. Because if we tried messing with that stuff, we'd likely screw it up for everyone. So we are just not given that level of privilege. So, and, you know, it's kind of like you don't have to worry about just, you know, malicious people getting in and accessing things they're not supposed to see. You also have to worry about just general levels of incompetence. You know, more a case in more a thing in my case than the TA's case, of course. But you know, if the amount of things you can do is limited, then the amount of damage you can do is limited, right? So if you're doing that damage inadvertently, it's still limited. But anyway, so let's talk about an algorithm for a moment. So switching gears. Switch gears. So linear search. When we talk about algorithms and algorithms research, there's sort of a number of like good intro examples that are used to introduce the concepts of algorithms, analysis, design, and this is kind of capital A algorithms. So if you continue to take computer science courses, you'll find that like data structures and algorithms is its own series of courses, right? It's also its own area of research. And, you know, while, you know, whenever you're programming, you're writing algorithms, but algorithms research with a capital A is, you know, it's an area of research with its own history and its own, you know, prestige and everything that goes along with it. There are like well-defined methods within the algorithms community of how you analyze algorithms and that sort of thing. So we're gonna dip our toes into it. One of the algorithms that's generally one of the first algorithms that you would see as a student of algorithms, capital A algorithms, is the search algorithm. So the way that a search works is you have a collection of things, and you're trying to determine if a particular thing that you're looking for is in that collection of things. So the most basic way of going about this is called linear search. And this is the way that you would do things if, let's say that you just moved into student housing because it's not a pandemic, and you have boxes with you, and you know your toothbrush, or you hope that your toothbrush is in one of those boxes. How do you find your toothbrush? You open each box and see if your toothbrush is in it. This is what you would define as linear search. So, an important thing to know about computers is, as I've said many times today, computers are dumb, like super, super stupid. A computer doesn't know anything. A computer doesn't know what's inside of, for example, a tuple, right? It just holds the stuff in the tuple. If you ask it, hey, is there a 5 in that tuple? The computer's like, I don't know, I just work here. I just hold that tuple. You know, you have to define what having a 5, you know, you the user, define what containment means by the manner in which you interact with the computer system, to some extent. Now, this is sort of broken down a little bit inside of the Python context, because we do actually have a dedicated searching operator, the in operator, right? So, you know, hello world, not Wallard. Python 3, hello world. So, O is in, hello world, true. So what, like, this is not Python just knowing that there's an O inside of this string. what's going on is Python is saying, oh, that's a search operation. So it actually performs the algorithm we're about to cover. It checks each one of these characters to see if one is an O, and when it finds an O, it returns true. That's what it does. Linear search searches through the elements of a data structure. Remember, strings are data structures, to find see if there is a occurrence of the thing you're searching for in the data structure. So there are a couple of different ways that you can do linear search. In the case of the in operator, we're just returning a straight boolean value based on the presence or non-presence of the thing that we're looking for, but we can also perform the index method over a string or a tuple or a list or a dictionary. Well, not a dictionary, but you can index. If you look for the index of O, that's also a searching operation. It goes through the string until it finds the thing it's looking for. The difference is, instead of returning just a true or a false value based on whether it found it or not, it's returning the index at which it found it. So it's returning more information it's returning more information about the string than just the in operation. And if you search for something that's not in there, you get a value error, substring not found. So, how would we implement index ourselves if we had to for an assignment or something like that? Well, I'm so glad you asked. Def index. Take a thing to search, we'll call it T for tuple, and an element to search for, we'll call it E. I is equal to 0, while I is less than the length of T. If T at I is equal to E, return I. So, if you manage to get through all the executions of that loop without having returned I here, then you know that the thing was not found. So then you return whatever you want to return in the case of search failure. In this case, let's return false. That's another thing about Python that's different from other programming languages. Normally you have to return, everything you return has to be of a particular fixed type, but in Python you can return whatever type you want. Because we're in loosey-goosey hippie land. So, if we have a tuple, T, or let's call it little t, that contains numbers and we ask for the index of, say, 7, quit Python 3 topic 3 .py bing bang boom. Then we get an infinite loop because your professor forgot to increment his loop variable as he said he would. Gosh darn it. There you go. It's not the end of the world to make a mistake. Fixing it quickly is the thing. Oh, we should probably print the result here. There we go. So we get our first 7 occurring at index 9. Which, of course, remember, we're starting from 0, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. Our first 7 occurs at 9. Good! So that's how you do an indexing operate. That's how you do a search. You just look through everything, check each one to see if it's the thing you want, using an if statement, and there you go. So, we're going to go through a few different versions of this, but the way that I did it here, this is considered by the author of the slides to be not the most the author of the slides would quibble with this construction, although it's perfectly adequate in that it works fine. Generally speaking, you want to try to avoid return statements in the middle of loops, return statements in the middle of functions in general. If you have multiple places, multiple distinct places from which a function may be exited, that tends to sort of work against the idea that functions should have one entry point and one exit point. Functions having one entry point and one exit point greatly increases their readability and their usability. So if we were to reformulate this, we might do it as follows. Rather than returning something immediately, we might use a break statement. So break statements immediately terminate a loop. If you hit this, then the loop is done. And then, once the loop is done, we can say if I is equal to length, then we know that length of t, then we know that we got to the end of the loop without hitting the break statement. You can also use a flag for this. Otherwise, we return I. I'll just show you what a flag is. Flags are super useful. Flags are Boolean variables that you can use to determine whether a particular branch of the algorithm was actually executed. So if we say flag is equal to false, and rather than breaking here, we set flag equal to true, then we don't actually have to worry about testing some esoteric property of I. We can just check the flag. If flag, then we know that we found the thing we were looking for. Otherwise, we didn't. There you go. Yeah. So one thing about this, we are only identifying the first occurrence of whatever it is we're looking for. Notice that Although with this one, if you wanted to change this index operation into a count operation, you could do that fairly easily with the version that uses the flag. So let's just make this count, and that's going to have to be called index2 in order for it to compile correctly. If we change this to C for count, started at 0, and every time we hit something that's equal to E, if we, instead of setting the flag to true, if we add 1 to the count, then when we are finished, all we have to do is return C, and that's how many instances we had of whatever E is in T. So there you go. Yep. So if you wanted to count the number of instances of the number 3 in there, you can see we've got 3 3s. 1, 2, 3. Ta-da! You should still break since I keeps increasing. Oh, has it? Okay. Yeah, that's true. Oh, yeah, that's right. Yeah, that would be mostly useful if you were returning true or false. If you're trying to find the index, then because I is continuing to increase, this doesn't actually interrupt it increasing, which would be a problem. My webcam. At least it's not a super goofy face this time. There we go. Thank you. So, and, just while we're at it, let's do one more version. So let's do index 3. So we are using this if statement inside of the loop in order, like we're using a conditional inside of the loop to determine whether or not the thing that we're looking for has been reached. But we don't actually have to do that. While I is less than the length of t, and t at I does not equal e, I plus equals 1. Return, and then you can use this guy. You could even, if you want, use that construction that the ternary expression to say return false if I equals length of t, else I. Return the value of I. And that's actually the exact same algorithm, but in 4 lines instead of 8. Ta-da! Very compact. So if you're the kind of person who likes to optimize for the fewest number of lines of code possible, which is not the same thing as efficiency, but perhaps it looks more aesthetically pleasing, then there you go. That would be a super compact way of doing the same algorithm. So you guys see what I mean when I say there are 100 million ways to write the same algorithm, right? Just an almost infinite number of ways. So let's see how many of those we hit in the slides. So, linear search but returns immediately. We did that one. Break statements, yes. We can use the break keyword to stop execution of a loop and jump to the next statement after the end of the loop. Yes, yes, yes. Break, break, break. We performed that one. Yes, yes. And yeah, so we got lots of stuff going on. Let me see if there are any questions. Nope, no questions. Moving on. So, the much anticipated for loop. So I'm going to level with you guys. It's actually, once you get up into the sort of higher tier material within this course, while loops will become increasingly rare, you will more and more be using for loops. As we continue on in this course, more and more of the operations that we'll want to perform will be applied to data structures. In Python, for loops are built specifically to iterate over data structures. So when you want to do something over a data structure, it just makes more sense to use a for loop. So the other nice thing about for loops is, well, before I get into that, let me describe what a for loop actually does. So for loops will go through each element in a data structure individually and assign a variable to that element of the data structure for one iteration of the loop. So let's take a look here. Let's replace this with a for loop. So count with for loops. Count 2. You know what? Let me just blow this up a little bit. I'm sure everybody's like, man, I wish that was just a little bit more easy to read. Settings. View. No. Tools? No. Text editor. Preferences. There we go. Font. Blow that up a little bit. There we go. There, that might be a little easier to read, eh? So, count 2. We're going to use a for loop this time. So, we want to count how many elements of the tuple are equal to the element E. For element in tuple, if element is equal to E, C plus equals 1, gotta set C to 0 up here, return C. There we go. Done. See how much easier that is? We don't need I. We don't need to remember to increment I. Essentially what's going on here is element. There's like an implicit step here. If you were to do element is equal to T at I, then and replace element here, that is like, you can recognize that as being the same line as this here, right? So this is implicit in the for loops construction, and the incrementing, like the going through each one behavior that we are producing in a while loop by using an indexing variable is just done for us automatically using a for loop. Very cool. So because there's no indexing variable that might go astray, or we might forget to increment, for loops are quite robust against the problem of infinite loops. It's difficult to get a for loop to do an infinite loop. It's not impossible, but it is more difficult. Any sufficiently clever programmer can break anything. Oh, that's interesting. Mark, who knows Python quite well. If you want speed, Python put all the optimization into for loops, while loops suck compared to them in most cases. So, for loops are even the better optimized solution. So, here are two programs. S is potato, I is 0, while I is less than the length of S. C is equal to I at S, print C, I plus equals 1. This just prints out each character in the string one after another. The same thing with a for loop is for C in S, for character in S, print C. And these things will do the same amount. These things will both do the same operation. The for loop does the same thing in half the lines of code. The for loop should not modify the variable, though. That's one of the things. One of the things that you might get into trouble with. No, that doesn't work. Just do that then. So, for S is equal to potato. For character in S, print S equals S plus character. Yeah. So in that case, it was bounded, but if you did that as a tuple, it probably would bork out on you. So S is equal to the tuple version. Maybe? I don't know. Maybe they fixed this. Well, anyway, doesn't matter. Moving along. So, one of the things that one of the things that may not be obvious is how you then do something like our factorial example and iterate through a number of numbers, so to speak. And well, it turns out that you can actually create data structures containing numbers on the fly using what's called the range function. So it's not... so if you call range 20, it creates what's known as a range object. You have to actually cast it as a tuple or a list in order to see what's going on really under the hood. So when you call range 20, you get the numbers from 0 to 19 all in a collection. So you can actually for loop over these. So for I in range 20, print I, you get all those numbers. There you go. And the arguments of the range function operate the same way as list slicing does. So with list slicing, it's like the first one is where you start, the last one is where you end exclusive, and the third one is how much you count by. And you can see we are going from 20 to 58, and we are counting by 2s. So this is, this is a way for you to be able to create data structures on the fly to be able to calculate things. So let's say let's just quickly do our factorial example then. For, we need an accumulator. So result is equal to 1 for I in range n plus 1, result times equals I, result is 0, because I did oh yeah, let's make that from 1 to n plus 1. And then let's ask for the result. It's still 0. Oh yeah, because it... There. Set it to 1. Set it to 1. Do that. Then do that. Result. There we go. The correct result. So all of that business where we had to, fiddle around with range object, or all that business of fiddling around with, indexing variables, we don't have to worry about that. You still have to have the accumulator, though. But yeah, I'm not saying there's no instance where you would want to use a for loop. It's just I'm not saying there's no instance that is inappropriate for a while loop. Again, every for loop can be expressed as a while loop, and not every while loop can be expressed as a for loop. So, while loops are a more general structure. You can do something with while loops like x is equal to input, enter a say please. And then while x does not equal please. Or, yeah, actually I screwed that up. No. While x does not equal please, x is equal to input, I'm not letting you go until you say please. I'm not letting you go until you say please. No. 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 Nah. 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 Potato. Please. And that ends it. So while loops are a more general structure. For loops are a bit more restricted, but they're safer and easier to use for the applications to which they apply. So I would recommend using them. So, the range object, then. I already talked about this, but so when you generate a range, if you have one argument, it goes from 0 to 1 minus that 1 minus that whatever it is that you specify. If you specify 2 arguments, it goes from the first one to 1 minus the second. And if you specify 3 arguments, you're also specifying how much it counts by. Note that these are basically the same rules as list slicing. So it's kind of like range 100, let's say 1000 from 60 to 100 by 4. Should be equivalent. Oh, sorry. Gotta use colons. Yeah. There you go. See? You can use the same arguments in a slice on, like, generating a whole bunch of numbers, and it works exactly the same. Although it does waste more memory. So. And I've already demonstrated that you can tupleize them, which I recommend if you want to ever actually view them. But it's not necessary for the purposes of looping. As I demonstrated up here, you don't have to convert it to a tuple in order to for loop over it. Converting it to a tuple does nothing except change how it can be printed, converted to a string. Cool. Oh, and it range only works with integers. So, for example, we can print a list of even numbers. Sure. I kind of already showed this, but sure. We can totally do that. Print a list of even numbers. N is 50. We're going from 0 to n by 2. Print x. There you go. Man. I really wish we could finish off these next slides in the next 2 minutes, but I don't think that's realistic. So, yeah, actually, rather than getting into any more slides, I think I will open up this floor briefly for questions. Does anybody have any questions about any of that? I know that Mark has sort of been answering questions as we go in the chat, which is extremely useful. But yeah. Yes. Yeah, yeah, you may consider class ended. The tutorials are hypothetically supposed to start at 12:30, which means you're not going to get any time for lunch, basically. So every time you run a code, it just makes space for another code. In Jupyter, you mean? Yeah. Like it opens up a new box. That means you're not printing anything. So, like, x is equal to 9. it doesn't print anything, right? And if I did that here, y is equal to 9, it does, like, when it executes it, it automatically creates another box underneath it. What you want to do is you want to include a print statement so you can actually have some output underneath your box there. So you probably just don't have any output. Go to Teams. The TAs will be making meetings, and you may join the meetings. So there you go. Yes. So if you go on Avenue, check out the announcement feed. There you go. There's a link. You gotta click the link to get to the team. Cool. Okay. It doesn't look like there are any questions for... pardon me. You're a little old professor. So, I will leave it in the capable hands of the TAs. Thank you very much for paying attention. I see our viewership numbers were relatively constant throughout this extremely long 3-hour time block. So, thank you very much. We will see each other again tomorrow. Is today the last day to drop the course? I wouldn't know, but the dates, the semester dates will be on the registrar's website. So, if you Google it, you'll find it. Bye bye, folks.